You're welcome to my YouTube channel. In this video, we're going to solve this problem involving circle geometry. And what we have here is this circle, and then we're asked to find angle BOD, angle OBD, and angle BDC. But we're given angles BAD. Where is that? BAD, that's this angle, 47 degrees, and angle DBC is what? 28 degrees. Which is this one here. Okay, of course, we're told that this diagram below, ABCD, lie on the circumference. Okay, ABCD, and this, what we have here, the center, here is the center of the circle, center O. Okay, so let's start with the first angle, which is what? Angle BOD. Let's identify angle BOD. Where is that? Angle BOD. BOD, that's this angle here. So how are we going to get this angle BOD? Now you must be familiar with some circle theorems for you to be able to answer some of these questions. Now look at this. This angle is at the center. So the theorem that we can use to answer this question or to find angle BOD is angle at the center, which states that the angle at the center subtended by this arc is twice the angle subtended by the same arc at any point on the circumference. Now look at this arc here. This same arc subtends this angle, 47 degrees. So this angle at the center will be 2 times the angle subtended by the same arc at any point on the remaining circumference here, which is this one here now. Now let me just redraw it here. If I draw a circle, and this is the center, I draw 2 radii, okay, with an angle here, all right? This angle at the center is subtended, is twice the angle subtended by the same arc at any point on the circumference. So if this is 40 degrees, this will be what? 80 degrees. That's it. This is what the circle theorem is talking about. So for us to get angle BOD now, it's very easy because we already know the angle at the circumference that was subtended by this arc DB. So I'm going to start by saying that angle BOD will be equal to 2 times angle what? DAB. So 2 times angle DAB. And the reason for that is what? Angle at the center. Angle at the center. So let me get a duster and take this off. This is equal to 2 times DAB. Angle DAB, that's 47 degrees. So what is 2 times 47 degrees? That's what? 94 degrees. And we're done. So easy. So the angle BOD is 94 degrees. Remember, angle at the center, okay, is twice the angle at the circumference subtended by the same arc. That's it. So the next question says we should find angle OBD. Angle OBD. So let's identify angle OBD. OBD. That's this angle here. Okay. Now, in case you don't see it, I already see a triangle. See, ODB. This one here is a triangle. Can you see? That's a triangle. And this triangle is an isosceles triangle. How do I know? Because it is bounded, or the 2 sides of this triangle, they are radii. So here and here, and they are equal. All the radii in a given circle are equal. So it means that this triangle is an isosceles triangle, which also means that the base angles are equal. So this angle here, that's angle ODB and angle OBD, they are what? Equal. So the question is, do we have this angle? Yes, we just got it as what? 94 degrees. So this is 94 degrees. And we know that the base angles are what? Equal. So I am going to say that angle OBD is also equal to what? Angle what? ODB. Angle ODB. What's the reason for that? Base angles of an isosceles triangle. Okay, if that's the case, so since we're interested in getting angle OBD, so angle OBD now will be equal to what? remember, for us to get angle OBD, I will have to subtract 94 from 180 degrees and divide it by 2. $94. So because if whatever I get from here, I will share it into 2 equal parts because the base angles are equal. What's the reason for this now? We can say sum of angles in a triangle. That's how we got 180. If you add all the angles in a triangle, it is equal to what? 180 degrees. So the sum of angles in a triangle. Beautiful. So what is 180 minus 94? That's going to be what? 86 degrees. 86 degrees. If you divide it by 2, you are going to get what? 43 degrees. 43 degrees. So angle OBD is also equal to what? Angle ODB. And they're both equal to what? 43 degrees. But we just got the angle for what? OBD, which is what? 43 what? Degrees. Okay, let's get the third angle. What's the third one? It is what? Angle BDC. Angle BDC. Where is it? Let's identify the angle. Angle BDC. BDC. That's this angle here. You see the angle? That's angle BDC. How do we get that? Now, we can already see a triangle again. Triangle what? DCB. You see? I have one angle in the triangle. I need to get this angle, but I do not have this angle. So if I can get this angle, it will be easy for me to get what? Angle BDC. So how do I get angle BDC? Or how do I get angle BCD? Very easy. Let's start off by getting angle BCD. So angle BCD will be equal to what? Now, there is another theorem that you also need to know, that the opposite angles of a cyclic quadrilateral are supplementary. By the word supplementary, I mean that they add up to 180 degrees. So see, opposite angles. This is a cyclic quadrilateral. DABC, because it is a quadrilateral whose vertices are touching the circumference of the circle. See, this one here, this one here, this one, this one. That makes it a cyclic quadrilateral. The opposite angles are supplementary, which means they add up to 180 degrees. Very easy. Since I already know this angle, and I know that if I add this angle to this one, it must be equal to 180 degrees. So that's very easy. I will say angle BCD plus angle what? DAB. That's this 47 degrees here. Angle DAB, angle DAB will be equal to 180 degrees. What's the reason? Opposite angles of a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral. Okay, now that we know that, now DAB is what? 47 degrees. So that's angle BCD plus 47 degrees will be equal to 180 degrees. When you transpose this over, you have that BCD is equal to what? 180 degrees minus 47 degrees. Now, what is 180 minus 47? That's what? 133 degrees. 133 degrees. Okay, I think it's easy to get this angle now. Since this is 133 degrees, remember that the sum of angles in a triangle is equal to what? 180 degrees. So to get angle BDC, I will have to subtract the sum of these two angles from 180 degrees. So I will say, therefore, angle BDC will be equal to 180 degrees minus the sum of the other two angles, which are what? 133 degrees plus 28 degrees. And what's the reason for that? Sum of angles in a triangle. Sum of angles in a triangle. Now, this is angles. I'm using this short symbol for angles in a triangle. Okay, so angle BDC will be equal to 180 degrees minus, what's 133 plus 28? That's what? 161. Yes, 161 degrees. And what is 180 minus 161? That's 19 degrees. 19 degrees. So, therefore, angle BDC is equal to 19 degrees. And this is the value that we have for angle BDC. So we have been able to get the angles for BOD, for OBD, and for BDC. Now don't forget the various circle theorems that we just looked at. The first one was what? Angle at the center. Then we also looked at an isosceles triangle because it is bounded by two radii. That makes it an isosceles triangle. And then we also looked at what? The opposite angles of a cyclic quadrilateral. I hope you enjoyed every bit of this video. If you did, kindly like, share, and subscribe to this channel for more content like this. I hope to see you in the next one. And again, do well to join my private community because this is exactly the topic that we are treating at the moment. I'll put the link in the comment for you to join my private community. I'll see you in the next video. It's bye for now.